In part 5 of this lecture, we're going to learn more about reliability and the different types that IO psychologists are interested in. In the field of psychology, we measure constructs. So we have a lot of tests. In the field of IO psychology, we have measures of performance and of KSAOs, knowledge, skills, abilities, and other characteristics like personality and values. We use these tests to evaluate employees and to make predictions about how they will behave in the future. Some tests are better than others. In order to determine whether a test is a good test or a bad test, we can evaluate its reliability. When you hear the word reliable, think of someone who is consistently there for you. You can rely on them no matter what. A reliable test is similar in that you can expect it to provide reliable, consistent, stable results. Our goal is to create and use tests with high reliability, plus or minus 0.8 to 1. When we use these tests, we get consistent results across time, across forms, across raters, and or across items, depending on the type of reliability that we're talking about. Keep in mind that perfect correlations, +1, -1, are extremely rare due to all the different types of errors that occur when we measure psychological constructs. No measure, no test is perfect. IO psychologists pay attention to these 4 types of reliability. We're going to cover each one on the next few slides. Use this table to help you study and compare and contrast the different types. When we assess test-retest reliability, we compare the scores from the same test and from the same group of people administered at 2 different times. Highly reliable tests will produce similar results at time 1 and time 2. If they don't, then the test may be unreliable, or there may have been some event like a training program or a pandemic that influenced the time 2 results. Equivalent forms reliability has a few different names. Some people call it parallel forms reliability or alternate forms reliability. This type of reliability represents how well 2 different forms of the same test compare. We would administer the 2 forms to the same group of people. For example, each year, the GRE, the Graduate Record Examination, is administered to thousands of college students who are interested in going to graduate school. The version of the test that you receive is one form. The version that someone else receives is another form. The test developers of the GRE are interested in whether you and that other person score similarly on the 2 different forms. If most people who take Form A fail it, but most people who take Form B pass it, the inconsistency between the 2 forms suggests that the 2 forms are not reliable. Equivalent forms reliability is useful when we're dealing with large test banks and large numbers of test takers. When we evaluate internal consistency, we look at the items within a single test. We could look at the internal consistency of Form A and the internal consistency of Form B. There are different ways to split up a test, but many people will split it into even and odd numbered items. The idea is to make sure that the items themselves are consistently measuring the construct you're measuring. Take a look at the example on the slide. Take a look at the second to the last row in the table. Form 1 has an internal consistency of 0.4 in the writing skill 2 area. What this means is that the items, and there may be 3, 4, 5 items, that measure the writing skill number 2 are producing inconsistent results. One item, everyone is passing. The other 2 items, everyone is failing. We would then need to look at those particular items and reassess our measure, our test. Not only do we care about the consistency of tests and measures themselves, we also care about the consistency of the ratings and decisions being made by humans, by the people who are in charge of administering the test, the measure. Inter-rater reliability represents the extent to which different raters agree with one another. In the graphic on the slide, you can see one person gave a 9, another judge 6.1, 7, 5.7, 6. These numbers are all over the place. On a 10-point scale, we have a high score of 9 and a low score of 5.7. I would say the raters here in this graphic are not consistent. The inter-rater reliability is low. What we want is for the 5 raters to be on the same page in terms of how they evaluate the behavior, the performance. 9, 8, 9, 8, 7. One of the reasons that we commonly use multiple raters is because there is evidence that it helps reduce error and helps compensate for different raters' bias. Some raters are extremely lenient, others are more strict and have higher standards. Different people think about data in different ways. By aggregating their ratings, we hope to mitigate some of these issues and produce more accurate data, more accurate ratings of employees' behavior.